write an expression for the gravitational potential. You can use your formula booklets to help you here. There's a table of data here. It says show that the escape velocity is equal to root 2 gm over r. Well, what we need to know is the kinetic energy related to proportional to v squared is going to be equal to the gravitational potential energy, and Ke is obviously half mv squared. Gravitational potential energy is just going to be minus gm1 m2 or mm over r. So we equate these two. Half mv squared equals minus gmm over r. M's cancel out, we rearrange, and we get v is 2gm over r, all rooted. Answer. Calculate the escape velocity of the gas molecules on Pluto. So again, using v equals 2 times g, 6.67 times 10 to the minus 11. Make sure you use universal gravitational constant, not gravity on the surface of the Earth, not 9.8, times mass, 0.131 times 10 to the 23. Take that from the table above you. And distance r, 1.19 times 10 to the 6. And the escape velocity turns out it's 1,200 meters per second. And finally, part 3. A lot of people made silly mistakes here. Explain why Mercury has no atmosphere whilst Pluto has a thin atmosphere. Use data from the table to support your explanation. Okay, well, we can work out that Mercury, okay, has a larger, a higher escape velocity than Pluto. Now, we've worked out the escape velocity for Pluto already. We can work it out for Mercury again if we want to, just using root 2 gm over r. Okay, so you might expect that it would have more atmosphere on Mercury. However, it doesn't. Why? Because Mercury is closer to the Sun and therefore hotter. That's the next mark. What does that heat mean? It means more kinetic energy, if you like, per particle, and therefore molecules on Mercury are more likely to have speeds higher than the escape velocity.